Now let us solve problems on Laplace transform. Okay. Let us find the Laplace transform for t e to the power of minus t sine t. Okay. First, let us find what is sine t. Okay, which is 1 by s square plus 1. Okay, by shifting property. So let us find e to the power of minus t sine t. So which is equal to 1 by s plus 1 whole square plus 1. Okay, this is f of s. Okay, now let us multiply with t, multiplication by t. We have Laplace transform of t e to the power of minus t sine t, which is equal to minus d by ds of f of s. So which is this is minus d by ds of 1 by s plus 1 whole square plus 1. Okay, or you can write as minus d by ds of 1 by, this is s square plus 2s and 1 plus 1, that is 2. Now differentiation with respect to s, we get as 2s plus 2 divided by s square plus 2s plus 2 whole square. Yeah. Now let us find another problem on Laplace transform. Laplace transform of 1 minus cos t by t square. Okay, so we will first find Laplace transform of 1 minus cos t, yeah, which is 1 by s minus s by s square plus 1, which is f of s. Okay, so now a Laplace transform of 1 minus cos t by t square. So integrate this twice with respect to s. Okay, so this is f of s ds and ds. Okay, let us substitute. Now this is integral s to infinity we'll integrate the inner integral 1 by s minus s by s square plus 1 ds and ds. Okay. So this will be log of s minus 1 by 2 log of s square plus 1. Okay, now we have the limits s to infinity. So we are done with the first integral. Now integral s to infinity. Now this will be log s by, now this will half of log s square plus 1, which will be square root of s square plus 1. Okay, keep under the brackets. Now still we have the limits, which is s to infinity ds. Okay, Then applying the limits, we get s to infinity. This will be log square root of s square plus 1 by s into ds. Then again integrating it. So this will be log 1 by square root of 1 plus 1 by s square. Okay, limits s to infinity. So let us substitute it. Log 1 minus log 1 by square root of 1 plus 1 by s square, or this will be log s by square root of s square plus 1, or this will be log square root of s square plus 1 by s. Okay. Now let us find the inverse Laplace transform using convolution theorem. Okay, so L inverse of s by s square plus 1 is cos t. Okay, and L inverse of 1 by s square plus 1 is sin t. So therefore, by convolution theorem, we have L inverse of s by s square plus 1 whole square, which is integral 0 to t cos u into sin t minus u du. Okay, so this is 1 by 2 integral 0 to t 2 cos u sin t minus u into du, or 1 by 2 integral 0 to t. Now this will be sin u plus t minus u minus sin u minus t plus u. Okay, into du. And so this is 1 by 2 integral 0 to t sin t minus sin 2u minus t into du. Okay, so let us use 2 cos a sin b, which is sin, since we have used that, sin a plus b and minus sin a minus b. So which is, this is half of u sin t minus half plus half cos 2u minus t. Yeah, u is equal to 0 to t. Therefore, this would be half u, substitute it, that is t sin t plus half cos t minus 0 plus half cos t, okay, which is equal to half t sin t, or t sin t divided by 2. Now let us use Laplace transform here to solve the differential equation, okay, which is d square x by dt square minus 3 dx by dt plus 4x is equal to t, given that x naught, x0, which is 1, and x dash of 0, which is minus 1. Okay, so let us solve that. So this can be written as x double dash minus 3x dash plus 4x is equal to t, right? Now Laplace transform on both sides. Okay, so this is a Laplace transform of t. Now this will be s square okay, x square uh, and now this will be x of t, right, minus s of x0 minus x dash of 0 minus 3 s into x of t minus x of 0 plus 4 x of t, right, which is equal to 1 by s square. And now this will be x of t of s square minus 3s plus 4, okay, minus s plus 1 plus 3 is equal to 1 by s square by substituting x naught and x dash value here. So after simplifying, x of t will be this is 1 plus s cube minus 4s square divided by s square and s square minus 3s plus 4. Now we'll use partial fractions here. Yeah. Now 1 plus s cube minus 4s square divided by s square into s square minus 3s plus 4, which is equal to a by s, b by s square, and this is cs plus d divided by s square minus 3s plus 4. Okay, so we get the value of a, b, c, and d. Okay, so after solving it, we get x of t as 3 by 16 into 1 by s plus 1 by 4 into 1 by s square plus 13 by 16 into s minus 29 by 16 divided by s square minus 3s plus 4. Okay. Now the inverse of this x of t will be L inverse of this whole thing. Okay. Yeah. So let us simplify this further. Okay. And then we get, finally we'll get as x of t, which is three by 16 plus t by 14 plus 13 by 16 e to the power of 3t by 2 cos root 7 by 2 into t minus 19 by 32 to 2 by root 7 e to the power of 3t by 2 sine of root 7 by 2 into t. Yeah. So this is the solution of the differential equation.